Now in this section we will look at top recursion interview questions that are asked during interviews at big companies like Facebook, Amazon, Apple and Microsoft. I took most of questions from the book called Cracking the Coding Interview by one of my favorite authors, Gail Lachman McDowell. The programming language that's used in this book is Java, so I recommend this book who wants to pass top companies' interviews. Throughout this course, I will use this book to explain real interview questions, and I will explain them in details to make our lives easier. Now let's continue the questions that are related to recursion. Now the first question is how to find the sum of digits of a positive integer number using recursion. So here we need to understand the question. So the question is, for example, if we have a number of 10, the number of digits in 10 is 1 because we have 1 and 0, so 1 plus 0 is 1. Now to create a recursion, as always, first we need to think about our first step. So what is the first step? So the first step is to find recursive case. So the question asks how to find the sum of digits of integer numbers. So let's see how can we find the digits of any given integer number mathematically. Now imagine that we have a number of 10. Now we need to somehow divide this number into digits. So how can we divide that? So if we look at this number carefully, we can see that if we divide it with 10, the result will be 1 and the remainder will be 0. So that's exactly what we want. So the digits of this number is 1 and 0. So if we divide it by 10, we are getting 1 and the remainder is 0. So if we sum up these two numbers, we can easily get sum of digits of 10, which is 1 plus 0 is 1. Now let's check this logic for another number. For example, let's take number of 54. So if we divide it by 10, we will get 5 and the remainder is 4. So as you see, 5 and 4 are the digits of this number. So if we sum up these two numbers, we will get 9, which is the sum of digits of 54. Now this works very well. And if we check this logic for any given two-digit numbers, we see that it works without any problem. Now you might be interested how this is work for example, 3-digit number or for 4-digit numbers. Now let's look at another example. So another example is 112. So if we divide it by 10, we will get 11 and the remainder is 2. So here 2 is the last digit of this number, so we can see it easily. So this is okay for us, but first two digits are still together, which are 11. So we need to separate this one also. So one more time we are going to repeat the same process by dividing by 10. So if we divide 11 by 10, we will get 1 and the remainder is 1. So the digits of 112 is 1, 1, 2, and here we have 1 and we have 2 over here. So if we sum up these numbers, we will get 4. So the sum of digits of 112 is 4. So we see that for 3-digit numbers, we need to implement the process of dividing with 10 one more time. And this means that we can write our recursive code like this. So here the equation says that this is the remainder, and then we are calling the same function for n divided by 10. So in this case, you see that we divided it and we get 11. So this means that we will run for 11. And here is the remainder, which is 2 over here. So first expression says that we are dividing n by 10 and putting over here remainder, and we are calling this expression for n divided by 10 if we have any value over there. Now we have found our recursive case, so let's see how can we write this recursive case. So here we have our main class over here. So inside this main class, I'm going to declare our function. So our function will be public function, and the return will be integer, and the name of function will be sum of digits. So this function will take as a parameter integer. Then we will write our recursive case over here. So as you remember, our recursive case was like this. So return, we are putting over here the remainder. So to find the remainder, we have a modulus function over here. So I will use it like this. This is giving us the remainder of n divided by 10, and plus we will run this function recursively, this one, for n divided by 10. So with this we have completed our method. So let's run our method to see how this is working. So for example, I'm going to run it for the parameter of 4. If I just put it over here, so here I have created main classes instance. So then I've declared a value which will get the return from this method. Then we'll print out that. Now if we run our code, you see that our method is inside infinite loop. So our method calls itself infinitely. Now how can we prevent this case? So we know that for this one we have step 2, which says that we need to find base condition for any recursive function to stop infinite loop. So let's think about what can be a base condition over here. Now here, I want to pause the video and think about what can be a base condition for this equation over here. Alright, let's see what's base condition for this equation. So if we look at our code over here, we can see that every time n becomes less and less. This is the nature of recursive methods, that we divide the problems into subproblems, which means that in most cases the base condition for a recursive method will be 1 or 0. So if we check this method for 0, for example, if we put 0 over here, we see that 0 is divided by 10 remainder and it's also 0, and the n divided by 10 is 0, so if we sum up this we are getting 0. So this means that we can use this as a base condition. So our base condition will be like this, n equals to 0. So if we just switch to our code and write our base condition over here, so before starting, in the first line of code I will write if n equals 0, then in this case I'm going to return 0. So if I rerun our function to see the sum of the digits of 4, you see that it returns 4. We have only one digit, so the sum of digits of 4 is 4. So if I put, for example, over here 10, if I run it, you'll see that it will return 1 because the sum of digits of 10 is 1. So it returns 1. So our function works the way that we want. So now we haven't finished over here because we have third case for recursive functions. So the third case, we need to find out unconditional case, the constraint. So let's think what we missed for our method. The tip here is we need to recheck our definition of the question. So in the definition of the question, it says that find the sum of the digits of positive integer numbers using recursion. Now in case of Java, if you try to call this method for float number, it's not going to work. It will raise an error because this case is also prevented, because when we are creating a parameter, we have mentioned that this should be the integer number. In our code, you can easily see that our parameter is integer number. So if you try to run it for float number, it's not going to work. It will raise an error. But in the definition of the problem, it says that we need to find out it for positive integer numbers. So from here, you see that we have to put a case to prevent this function to find for negative numbers. So our unconditional case will be based on this. So the question is, if we run our method for negative elements or floating numbers, what will happen? So I have already answered the question of floating numbers because in this case Java will prevent it. For negative numbers we need to put unconditional case because in our question says that we need to find a positive integer number, so we don't need to calculate it for negative numbers. So I'll switch to our code and write another condition over here like this. If n is less than 0, we will return 0. Now if you run it, for example, for minus 10, you'll see that it's going to be returned 0. So here we can improve our method like this. So instead of putting the if condition over here, we can put it over here. We can put or n is less than 0, we will return 0. So I can remove this code from here. So if I run our code one more time, you will see that it returns 0. Now let's check our method for example, for 3-digit number. So if I put here 111, so the answer should be 3. So as you see, the answer is 3. So our method works the way that we want. So in these 3 steps, we have implemented Java method for summing of digits of numbers. So here we have shown the 3 steps, then we have implemented in the practice. So hopefully you have understood everything. So with this, we have completed this lecture. Now in the next lecture, we will look at another question. So see you in the next lecture.